processing. Our first speaker is Dr. Kokil Jaidka, who has been working with my group for a number of years in doing computational linguistics scientific summarization tasks. But she's also been overseas for a number of years working with Dr. Lyle Ungar at the University of Pennsylvania on a lot of things that are related to social media. So today she's going to be talking about quasi-experimental methods for social media analysis. So let's have a round of applause for Kokil.
Thank you. Okay, hi everyone. Can I just get to know you a little bit? Are you undergrads, graduates? Okay, how many of you are undergrads? None. Masters? PhD students? Okay, awesome. And have you worked with social media language in any of your work? Yes? No? Yes, okay. Thanks. Awesome. Okay, so I just wanted to know what your background was in. It would help me a little bit. As Min mentioned, I'm Kokil and I'm currently at NTU. Before this, I was at Penn for 2 years. I was a postdoc there, and before that, I was a computer scientist at Adobe Research. My goal through my research is to advance theories about communication through using computational linguistics. So I'm what they call a computational social scientist, someone who uses computational methods, especially focusing on language, to understand and explain communication theories, to test communication theories, to see whether what the theorists, the social scientists expect to happen is actually happening through data. And these are some of the universities I've been collaborating with in the past 3 or 4 years, and these are the companies that have most recently and are still sponsoring my present research. The one Microsoft was the collaboration I had with Min regarding scientific summarization. And data regarding people and what they do is everywhere. These are some of the data sources that I've used in the past few years. Everything from email subject lines to Amazon reviews to crisis text line data and traditional surveys. They all have signals that computational linguists can use. And because all of you are here and you do, I'm guessing, work in some way with language, it's not surprising to you that language is so important in the research that I do, perhaps. Language is not about what words mean, although that is a significant body of research as well. For me, language is more about what people mean, what they say, what they don't say, what they intend, how that reflects their personality, how that reflects their context and their opinions. I find that having a multidisciplinary perspective, that is not just computer science but also psychology and communication, helps me frame my ideas better. I'm going to be spending a lot of my time today talking about a way of approaching computational linguistics that's a bit different from what we typically do in our papers for our conferences. It's going to give you a new way to think about problems that you've been working on so far. While if you think about it, a lot of problems that involve language modeling have a very straightforward cross-validation setup. It's predictive modeling. For example, a lot of my work has looked at modeling personality and conversation traits from social media posts. That is figuring out the intent of what was written, figuring out how much control people are expressing or what personality traits they're expressing through their language. And how these papers have mostly worked is that I collect the social media data that people post, be it on Facebook or Twitter. I also connect it with something else which is outside their language, such as their age or gender or their health. And I use these signals together in language analysis to get some predictions, that is to look at how the distribution of words predicts something they do offline or who they are offline, and to look at insights. And this set of problems is interesting. It is also somewhat boring. There are new challenges to be considered, and there's only so much it can reveal to you. We have to remember that these relationships that we find through these methods are correlational, not causal. You can't say that just because I use the word apple a lot, I am in New York. You can't say that just because I use the word apple a lot, I'm very healthy. I could just be a Apple fanboy or fangirl. Nevertheless, there are some beautiful things you can do with words. There are ways. It's useful to psychology where the deep revolution, so as we call it, hasn't yet reached. You can use it to understand people's personality traits. So in working with psychologists, this is work out of my lab, not my work. In working with psychologists, we find that looking at words and word phrases is predictive of their personality traits. And what you're seeing here is coefficients of regression plotted in terms of their importance. So we have correlation strength, which is bigger words have a higher correlation, and we have relative frequency, that is how frequent they were. For example, great night wasn't too frequent, but when it did occur, it was a strong signal of extroversion. So language does create explainable insights, which are useful to understand people. We have a similar slide for introversion. Apparently, introvert people are really into anime and Pokemon and the internet. Yeah. So while looking at all of this work, I started thinking about things along a slightly different track, which is fine. These relationships are great, but are they causal? Can we use them to understand causal mechanisms? What makes people express these things on social media? Why do they do it, and what does it mean when they don't? So that's where my more recent work comes in, where I am testing the theories about political communication, specifically things like campaigning, opinion expression, and so on. I'm testing those theories using similar methods, and I'm going to talk mostly about this paper, which is where I use quasi-experimental design on social media data. Yes.
So I was wondering about the last slide. So can you tell us a little bit about the structure of what that means?
Yes, sure. I thought I was getting into too many examples, so I skipped it. So there are different ways of engineering features from social media data. You can put all the language in and get a set of regression coefficients, or you can follow a topic modeling approach and you can get a separate set of coefficients. So what this slide is showing is the coefficients using two different kinds of models in a visual form. So like the previous slide I showed you, when you put in 1-grams, bigrams, and trigrams, what you get are these words which are predictive of gender. And you can guess which gender this is. This is rather stereotypical, yes, I agree. But these are also results of 2007, so a lot would have changed since then. Yes. So we see that words such as excited, love you, hearts, shopping are predictive of females if someone uses them on social media data. But we get even more signal when we use topic models, that is latent Dirichlet allocation, to generate topics and then look at those topics as features in the classifier. Then we get more coherent set of themes. For example, this theme is about family, this is about love and sweetheart, this is about boyfriend, this is about birthdays, this is about puppies and cute things. So they're just different ways of engineering features, and the slide is summarizing those results. There's a similar slide for males, which I've not put in here because it uses too much of the F word. But that's apparently most predictive of it being a man on Facebook. Some background about this data. This data was taken from, this data is the My Personality data set, which comprises 70,000 people who took a survey and shared their Facebook data. It is not the contested Cambridge Analytica data set. It's kosher. It was created using consent by Mikhail Kosinski and Stilwell. All right. We can go back into this if needed. I'm going to proceed So as I was saying, those are predictive modeling tasks. Now what I'm going to talk about is explanatory modeling, which is something that social science does, and which would be interesting to think of as a new approach to computer science and computational linguistics problems. In explanatory modeling, what we try to do is to use language to explain what's happening, for example, in political communication. And for example, this paper, which I'm going to talk about today, is how to use social media data in a quasi-experimental framework. Big words, simpler meaning, I'll get into it. In other work that I've done, I have looked at how that explains how language on social media can explain opinion expression, how it can explain patterns of interaction between who interacts and doesn't interact on social media. So this is one paper just got split up. And finally, also to look at how social media opinion varies in relation to the mass media opinion and what are the relationships amongst the two. What I'm trying to say is there's a lot of potential about where you can apply computational linguistics approaches. For example, you can look at it, you can use it to understand how the things that social media giants like Facebook do changes the health of online communication. Now, this study is motivated by the current discussion and concern about the health of online platforms. And Zuckerberg says that the goal of these social media platforms is to give everyone a voice and give people power. And what he thought initially was that the system will end up in a really good place. And the role of Facebook and social media is to give people power. Unfortunately, this is not really the case. People don't usually enjoy their time on social media. Um, this is research from the US. This was a survey done in 2016. People were asked, in your experience, when you talk about politics with people on social media whom you disagree with, do you generally find it to be interesting or stressful? And you can guess what they said. They said they find it stressful. And when they were asked why they find it stressful, they were asked, thinking about all of the places outside of social media where people might discuss politics, are the political discussions you see on social media respectful, civil, informative, or angry? More people were likely to say that discussions on social media are overall really angry, and that's what stresses them out.
So what are the other two colors?
The other colors are with respect to more, same, or less. So the other colors are with respect to the different options they were given.
I see.
Yeah. So they were likely to say that social media is more angry in terms of all the places where they ever talk about, where they ever discuss politics.
I have a point.
Yeah.
So I was wondering that, like what Mark Zuckerberg says
Yes.
is that to give power to people, right?
Yes.
Through social media. But so that is not quite related with whether they are angry or respectful, civilized in social media, right? They are two different things.
Yeah.
So, I mean, indeed, social media gives
Yes.
power to the people, right?
Yes.
Yeah, I mean, there is no disagreement.
Yes. What I feel, the point I'm trying to make here is there's a conflict between what Zuckerberg said, which is to give power to the people and to help them express themselves, and the reality, which is that people are not enjoying themselves enough to enjoy that power. So the point I'm making is that the goals of social media platforms were really lofty, in the sense we'd have this open, deliberative, participatory environment where everyone is equal, everyone can participate, everyone can express themselves. But what we are finding is that people are not really learning new things.
But that is also true in real life scenario. Like suppose we are having a conversation on politics.
Yeah.
In this room.
Mm-hmm.
I don't really think we can change.
Absolutely, you cannot.
It will be full of anger, emotions.
Yeah.
But if we talk about academics, for example, the Twitter community of academia, they are. I think there is a full of positivity.
Yes.
Not anger. So it
Yes.
really depends on community to community, right?
Yeah. So in the specific domain of politics, the idea was that because people can't see each other, and because they can only use the signals they're getting on social media platforms, it's kind of it's not a blind peer review, but it's some kind of blindness that's imposed on them to force them to see everyone the same way. It would overcome some of the problems that happen in real face-to-face scenarios. But instead, what we see is that people are finding it even more toxic than having a real life conversation. When you're standing in front of someone who you know has a different political opinion, you will always expect to be stressed out and you'll always expect to be angry. And what most of the theorists said was that because now everybody is on social media, some of these signals would go away. You wouldn't have to worry about what that person is wearing or what slogans they're making, because you would only see them as a profile picture. But instead, what's happening is that it's even worse than having a face-to-face conversation with someone. And this is a problem because ideally social media could have been the equalizer that would bring everybody together. Instead, it seems to be, or some research is indicating that it's driving them apart. As computational linguistics, you can see your role, because you're so good with language and you're so good with language models, in helping researchers understand whether this is really happening and to help them measure it, right? Okay, so that was the point I was trying to make. Now, unfortunately, these people didn't. Unfortunately, when these platforms are engineered, they don't really build. They don't really think about all the implications, and perhaps they did not plan for social media to become such a toxic place. So, what companies and governments are doing now is they are banning accounts. Uh, they are banning social media platforms altogether. This study specifically talks about how countries can control the narrative on social media by pushing some particular topics above other topics. This is happening a lot in India as well. They can flood the online community, and all of these things can be easily measured with language, right? But there are problems here, because when you do this, you are drowning out some other voices which are more important. You can issue interventions, which is you can block certain people, or you can issue them warnings that, hey, listen, your content isn't up to the mark and you should improve your content. But this is not scalable. These two studies have shown that to a small extent, having someone police everyone on social media helps a little bit. Having someone moderate the comments, for example, on a newspaper article, helps. But how many policemen can you put on social media? Now, what my work is proposing is that we can use language to understand whether designing better platforms can cause the language on platforms to change. Okay, I'm going to repeat that. Designing better platforms can cause the language to change. So, unlike my predictive modeling problems, language is no longer a feature, but what I want to measure the change in. So it becomes a y, not an x. Okay? In the larger scheme of things, you can start to think about this problem in terms of where it lies in the causality spectrum. Longer posts, for example, posts on Facebook, which are longer than posts on Twitter, are related to richer self-expression. There's a body of work that showed that, and my own work has shown that people tend to reveal more about themselves on Facebook rather than on Twitter. But relation, that is correlation, is different from causality. What I'm interested in and what I'm going to talk about now is how to show the causal relationship between longer posts, for example, and the effects on self-expression. You can replace these. The idea is that you should be able to understand how you can replace these with any outcome of your interest, but think about it in a causal framework. So the takeaway today is going to be the design of social media platforms affects the health of online conversations. And some papers have shown that there are differences which are related to differences in message length affordances. Affordances is a fancy word for technical design features. Differences in message length are related to differences in the disinhibition effect. that is related to differences in how people express themselves. And studies have shown that on YouTube and for news website comments, for longer and shorter Facebook and Twitter comments, and yet another study on Twitter and Facebook. The missing link here is that there's no causal study, and there are too many things that are different across the different platforms. But what happened in November of 2017 was that Twitter changed its design. From 140 characters, you could suddenly post 280 characters. That gave me a quasi-experimental design where I could test whether that single change made a difference in how people were talking online. You with me so far? Awesome. So that means over there I could actually test whether longer messages were causing different self-expression in the same people and on the same platform. So the research questions, following a language modeling approach, the research questions were: what effect did doubling the character limit have on the characteristics of political discussions? Straightforward regression. What are the effects for different bandwidths? Now, one thing that we all do as computational linguistics, as computational linguists, are that we decide the parameters beforehand. What's important sometimes is to take a step back and to think about how those small choices that you make might be affecting your outcome. In this case, if I look at the effects for a narrow window of time, 2 days versus 3 days, versus the difference 5 days from now and 5 days later after the character limit switch, are my results changing? So it's important to show that your results are steady for the different choices that you make. What are the average treatment effects amongst the compliers? Think about it this way. If there's ice cream in this room, 5 of you have it, 5 of you don't, and some of you develop a stomachache, I am only interested in the causal effects of that ice cream causing a stomachache amongst those who had the ice cream, right? Those are my compliers. Amongst the people who use the extra characters on Twitter, was there a change in their language, not just everybody's language? So those are the compliers. What are the average treatment effects amongst the compliers? There are some other checks that need to be applied to make this truly causal and to remove other possible sources of error. Self-selection check. That is, maybe I just like talking more than you. Maybe I was always likely to say things a different way, and I will be more likely to use the extra characters, a different way. So a self-selection check would control for individual differences between you and me on Twitter. Another check, the robustness check. Now, if you think about it, the way we measure language features, linguistic features on social media inherently takes the length into account. Everything we measure is in terms of its relative frequency, its relative proportion. And this check specifically considered whether there was a problem in how I was operationalizing those features. Finally, another thing, and a lot of these ideas are borrowed from the econometrics framework. Another thing that people like to check for is that if you're looking at causality, is it an accident? Is it a freak of nature? Was everything increasing, and was everybody just getting a stomachache, and that is why you found a significant effect? So what I did was I ran the same experiment at a different interval of time where there was no change in Twitter's framework to see if I was accidentally getting the same effects. The whole idea of this slide is, in designing a causal experiment, you have to think about every possible source of error and control for that, and show the robustness of your results in all situations. Now I'm going to talk about the dependent variables. These are things that will be more familiar with you if you've been working with language data. So as I mentioned, now language stops being a feature in my model, and instead it becomes the thing I want to predict. My data set was 350,000 Twitter replies to US members of the Congress between Jan 2017 and March 2018. filtered from the random 1% sample. Twitter changed the character limit on November 7th, so I had enough time before and after the change for my analysis. I looked at a bunch of different characteristics, and why I chose these particular characteristics are related to political communication literature. Political communication researchers are interested in incivility, which is how uncivil people are. They're interested in thinking style, which is whether people are giving rational arguments. And they're interested in relevance, whether people are staying on topic when they talk about something. And going a little back into the classifiers that I used, I can talk about that a little later. I used a classifier developed on tweets from Davidson and Weber for offensiveness, a dictionary developed on political comments for uncivil words. For swearing, I used linguistic inquiry and word count, which is basically a bunch of swear words. And for politeness, I used the Stanford Politeness API, which is again developed on a bunch of different data sets and does a pretty good job of finding the polite words. Now, the motivation behind using this particular data set was just the people I was working with, and the problem we were interested in is our discussions on politics becoming better now as compared to earlier. But you can think about how a similar framework would be interesting for other discussions as well. Okay, as I mentioned, analytical thinking and cognitive processing are how people show sophisticated thinking styles versus narrative, thinking aloud. But they're both signals into how much reasoning people are putting into their tweets. And finally, relevance. Okay, so as I mentioned, the first thing that we need to do, or the first research question was, what effect did doubling the character limit on Twitter have on the characteristics of political discussions? This is called an interrupted time series formulation, but it's really just a regression. We see y, which is the dependent variables such as incivility, rationality, politeness, and so on. We have t, which is the relative time distance from November 7, 2017. So it's a number that increases, for example, from 0 to 100. X is a dummy variable that indicates whether the tweets were published before or after the intervention. So this is a pretty straightforward regression equation, and this is called an interrupted time series framework. Things are getting a little more complicated now. The next thing we want to test for is a regression discontinuity design. As I mentioned, we want to look at the stomach aches for people who actually had the ice cream. So we are estimating the effect amongst those who actually complied with the treatment. Okay, so these Y are people who complied, and the approach is the running variable is the instrumental variable and the binary and it's binary, encoding whether the number of characters was greater than 145. There are more details about this. I've left it out specifically so that this doesn't get too much. The idea again is to just look at the treatment effects, that is the difference between before and after for those who complied with the treatment. Finally, as I mentioned, maybe I just like to talk a lot, and I would already be showing a different behavior on Twitter. So we add another variable at the end, which is unique for every single user, to make sure that we're looking at differences within users. So for the same person, did they change their behavior before and after? All right, I'm going to go into the results now. The first result was that with 140 extra characters, political tweets on Twitter became more civil in 3 out of 4 operationalizations. And what makes me think so? Well, this is the lowest plot, and I've intentionally blacked it out so that it's not too much. But what you see here is that there is a jump between this gray line and this gray line, which means there was, at this particular time, which is when the character switch happened, suddenly there was a drop in the use of uncivil words. So just look at the gray lines for now. We see the same thing here. Gray line drops suddenly, and in In this case, we see this is politeness, the gray line goes up. So now that you're with me for the gray line, and you see that there's a significant change in civility, we look at the blue lines, who are the people who actually ate the ice cream. So we see here that there is a huger drop here, and a bigger increase in, an as big increase in politeness here. So in all the cases, usually this is one of the plots you see in a causal study. This is showing you that your intervention, the fact that Twitter changed its design, changed the way people were talking on Twitter. Okay. The next result, that was civility. We see the same thing for analytical thinking and cognitive processing. Again, we see a jump over here. Yes, we see a jump over here, but the result was not significant. It was significant only for the blue guys, who were the compliers, but not for the overall ones. And here we saw no significant change in general, amongst the mean. And finally, for relevance. Now, this is important because if you have more characters, maybe you're going to go off topic and not talk about politics anymore. So this is a sanity check to make sure people are still talking about the important things. And surprisingly, we found that with more characters, people's discussions were less relevant to politics, which is a trade-off. So people are becoming more polite, but they're talking less about important things. It's concerning, but it's not surprising. Some political researchers have said that in being too polite to each other, sometimes we miss out on actually having a stake and communicating something of importance. Yeah.
Yeah, please. Go ahead. Oh, okay, thank you.
Yes.
Okay, so I wanted to see that did it check or could it check that when the system fails?
Yeah.
Because there are two things. So
Yeah.
if the system has access to very limited number of limited amount of data, like just 140 characters per tweet,
Yeah.
is there anything such that if less data, then less accuracy? Like the bad performance or the incorrect performance or the error might cause due to the less number of characters or less number of data available due to the Twitter policy. I mean,
yes, no, that's a good point. And in fact, I would recommend everybody. This is something I discovered through my work with social media data and through my discussions. Is that because these individual signals are small signals and unsteady signals, the best way to enrich your data is either A, to get 100% data, or B, to sample with replacement. That is, bootstrap your data collection and resample on it. So for example, for me, the unit of analysis was 1 day. So all the tweets and their features were aggregated on a per day basis. So to make sure our results were robust, because tweets are so small in length, we resampled our data again and again.
Okay.
So we made sure that a daily sample was at least 700 tweets.
No, I was saying, suppose so before Twitter changed its policy,
Yeah.
so we had only 140 characters.
Yeah.
Now, now can we create a data set which is in a synthetic data set?
Right.
So what do we do? That
Okay, you're saying that. Okay, I think I understand what you're saying. What you're saying is that before the character limit, the tweets were so small that it's possible that the error there was
By the
correlated
system.
with the length
exactly.
issue. Yeah, that's a good question. Which is why I put in the last check, and I artificially looked at only those tweets which were more than 135 characters in length.
Okay.
The idea was that if I do that, then tweets which are between 135 and 155 characters in length would have the same kind of error. Okay, so what I was trying to do there was to control for those kind of prediction errors where language is correlated with the length, language features.
Maybe another experiment would be that you create a synthetic data set where you suppose you just sample from the polite tweets,
right,
and which are of 140 characters or less than 140 characters,
yeah,
and just append few like tweets to it to make it to 80 characters.
Okay.
And then see that how the classifier performs, that whether the length really matters or
the length does usually matter, in fact, and length is usually baked into some of these classifiers, which is why sometimes I had to retrain them. So yeah, validation of classifiers in the most cases, except for offensiveness, I left to the original things. But for offensiveness, it was important because length is usually one of the predictors, as you said. So I had to retrain it on a data set where the length was artificially the same, or actually realistically the same, because I used only those training samples.
Yeah. I mean, you are really dealing with a very difficult problem, and I'm so glad to see that you have different parameters to actually check the quality control of the output. I mean, this I don't see often in
usually, which is the whole point, that there are so many things at play here.
Yeah, you have so many checkpoints. Very nice.
You had a question?
Yeah, just a quick question: whether you consider tweets that were adjacent in time as a thread, and then whether you put them together as a single tweet or you kept them separate.
That's a good point. We kept them separate. We used the 1% sample as is. So we didn't. If we were to do that, we would have to go back and resample or pull more tweets, and that would create new biases in the data.
Do you think there are some of your data set where a particular person who tweets will actually use several different tweets to compile a complete statement rather than use a single tweet to encompass everything they want to say?
I think that's a possibility, which is why we're presenting our results or aggregating our results at the day level. So what we find is the effects, if we look at it that way, we still find effects at the tweet level, and we still find effects at the message thread level. We find the results are most explainable and strongest at the day level. That's just how it works. At those lower levels, usually we do not have enough statistical power in our results. So I would still believe that these results hold, but possibly the effects are even weaker.
Is this because of the discourse structure?
I'm thinking, sometimes you start off a tweet with some type of inflammatory remark to get attention, and then you might bridge the more civil parts and follow up parts of it.
Yeah, definitely. And to find those things, it would be right to do a thread level analysis. All right. So to recap, what we've done so far is we've found that there is a significant effect on the incivility, the relevance, and the rationality, that is the thinking style that people project in their tweets. Now, the next thing that we wanted to check for was whether the findings are stable, whether using the magic number of 100 days before and after had anything to do with my results. This is an example graph, and I got similar graphs for all of my features. Basically, what this is showing you is that for different t, right? If you remember, I had a t which varied from 0 to 100. For different t's, the effect sizes beyond about 30 are all significant. The significance levels are below less than 0.05, 0.01, 0.001, and they're all less than 0, so they're all consistent in sign. These plots are just encouraging to say that these results are robust. They're not an artifact of the choices I made as a researcher. Okay, so I'm going to recap the results now. We're at 2:15. With 140 extra characters, tweets are more civil, and now I can say with confidence that there is a causal relationship between Twitter increasing its character limits and tweets becoming more civil. Tweets show more analytical thinking and cognitive processing, that is higher rationality. Tweets are unfortunately less relevant to politics, that is less substantive. They're more likely to digress. It's a good thing and a bad thing, as we can discuss. Findings are stable across different time periods. That is, as I showed you in the last graph, doesn't matter what T I use, accounting for self-selection bias, that is even amongst the people who had ice cream, beyond placebo effects and limitations of how the DV was operationalized, that is the fact that there's more error in smaller tweets. Theoretical implications. There are causal effects that we found, but they have important theoretical implications as well. Less substantive discussions, as I showed you that we are finding lesser relevance in tweets after the character limit change. Lesser substantive discussions imply the absence of actual deliberation or consensus building. People are so busy in using the extra characters and putting in more words that perhaps they lose track of the argument they were trying to make in the first place. Changing social norms implies changing political interest and political engagement. Think about it this way. You join a new school and everyone there talks a different way, or there's different rules of what can be said on and off the playground, and your interest in playing football will drop as a result because you can't communicate with people around you anymore. And that's the point I'm making here. By simply changing its design, Twitter can include or exclude people. And a good way to measure this change is to use computational linguistics. Stricter social norms can marginalize counter narratives and create echo chambers. If certain words and certain people can't get their voices out, it might be creating the echo chambers that everybody's talking about so much on social media. These are pretty weighty implications, and while my study is only hinting at these, in future work I'm looking to test each of these with more evaluation, more robustness checks, and social network analysis. There are limitations to any study, and as computational linguists, we should keep these in mind. We don't often think about the sampling bias. We do think about overfitting. Sometimes we think about causality, but sampling bias is important as well. As I was telling Saujanya, social media data is highly erratic, especially if you're using it to understand discussions. What's helpful is to follow a bootstrapping approach, that is to sample with replacement, make your data set stronger, run everything 1,000 times and average the effect sizes. A tenfold cross-validation doesn't always cut it. In my future work, I want to explore more of these problems using different methods, surveys, to understand better about what people are offline, experiments to actually manipulate these things and stop it from being a quasi-experiment and into a real experiment, and observational data similar to what I presented here, where I'll be looking at how Singapore talks about the people in its midst. There are, of course, ethical concerns with using social media data that I'll go into if needed, but everybody is pretty much aware of these. What I'd caution you as computational linguists and future researchers is to be careful about considering what biases are baked into your data before you do anything with it. Thank you. I'd be happy to take questions.
Yeah, we have a couple minutes for questions. For those of you who stepped in to see the second presentation, we'll be starting that soon. We had a